If you like my dad's videos, please subscribe to QA Insights channel. So today we are having Lloyd from Neocortex. We'll be talking about global last mile load testing. So last week we had Leandro about his new book. We interacted, and by Monday I'll be announcing the winners. So who is going to get the book from Leandro? I will announce in the LinkedIn. So now let's get started. Hi Lloyd, how are you?
I'm just great. Thank you very much, Naveen, for inviting me to the Clubhouse.
Thanks, Lloyd. Just a quick reminder, this session is being recorded. Once the session is ended, I will publish the recording in my YouTube channel, so please check it out. Now let's get started. So Lloyd, I would like to know first thing about the today's title. So what is global last mile load testing? It's kind of a new term in the industry, or is it been there for a while? Could you please explain the term?
Yes, of course, and happy to give a little bit of history of the idea. So I would say that this is an idea that has been around for some time. There was a company maybe 10 or 15 years ago called Gomez that did an early version of what we were doing on PCs. So the idea with Gomez was they would use compute power on people's PCs, and so they created a network of load generators. I think all over the world, using the compute power of people's PCs. And I believe that they had a reasonably successful business in the early 2000s up to 2013, something like that. And then they were acquired by a chain of companies. But ultimately, we don't really know about Gomez anymore. So that's sort of ancient history. But that was the origins of the idea of using people's computing devices to provide load generators to simulate load on website software. So that's the general idea. What Neocortex is doing, which is similar, is we're using the compute power of people's Android phones. So with that in mind, let me describe just a little bit about what Neocortex is, and then you'll be able to see how it is that we came to be working in this space. So I didn't conceive of Neocortex originally as a load testing company. I conceived of it as a brain-like computing company that would use the power of the world's 2.5 billion cell phones. So it was intended to be this massively scalable computing architecture that would use this huge compute resource, 2.5 billion cell phones, that's 92 exaflops of compute capacity, $60 billion a year worth of revenue at charging at Amazon EC2-like prices for that amount of computing. So it's a huge amount of compute, incredibly valuable, potential recurring revenue, if we could harness the power of that computing for real-world applications where we could find markets for it. Right? So I've told the story on LinkedIn of the thin layer of gold dust covering the Earth. That's one way of looking at what Neocortex is doing. All of the cell phones covering the land surface area of the Earth represents an enormous economic resource, kind of like a thin layer of gold dust. And the trick here with this company is, how do we monetize that? How do we find a way to bring all that compute capacity into a useful state? How do we make it useful and accessible so that it can be applied to real commercial applications? And one of those first applications that we came up with was load testing. It would be a perfect resource for testing for testing the performance of people's websites, but it would be using the power of real-world cell phones And one of the byproducts of doing this with people's cell phones, not phones in data centers, not phones that we purchased, but phones that we rent time on from real phone owners, then is that these phones that would be doing load testing would be located in people's homes. Now, that's an interesting property, right? That means from a computing point of view, they're not the highest performing computing application, right? Data centers have extremely high bandwidth trunks that bring enormous amounts of traffic into high performance data centers, and then inside the data center they have a huge amount of bandwidth for internal communications. Here we're using people's residential internet connections and Wi-Fi networks to communicate with them. So they're not the most high performance network of devices, but what they are is an extremely realistic network for simulating actual consumer traffic. So that gives us this unique resource, load generators based on mobile devices in people's homes, in real places where people actually shop from. So that means that's where the name global last mile load testing comes from. We're able to use these devices to do load testing, but they're distributed evenly throughout the world, proportional to where the population of the Earth is. So that makes it a global load test, at least potential to be a global load test, and a last mile load test because the devices are located in last mile locations, people's living rooms. As Tom Lunabos told me in 2017, he was the founder of SOSTA, which is one of the oldest load testing companies. Tom said, aha, you can do something we've wanted to do for a long time, which is you can tell us about the response time and performance to the living room in Oklahoma, not to some data center in Oregon West, right? But to the living room in Oklahoma or the coffee shop in Boise, Idaho. Right? You can tell us what the real end user response time and experience is, which is different than what you would measure as a performance engineer to the nearest high performance data center.
Correct.
So there we go. I'll pause there.
Yes, Lloyd. So apart from the load generation use case, so is there any other thing we can do, like can we run some small website or some instance using this approach?
Well, it can be done. However, we haven't. So you're talking about using Neocortex devices as web servers,
That's correct.
for
That's
example.
correct. Yes. Yeah. For example.
Yeah.
Yes.
Yeah. Yes. So yes, it can be done. We have not particularly focused on that market, partly because the website storage, website server function implies also persistent storage. That you're going to store the contents that you want to serve on your website, and these phones are not like enormous disk drives that would be associated with a cloud service. You know, Amazon, for example, is not just Amazon EC2. That's not their only service. They also have Amazon S3 as one of the basic pillars of their service. So storage and computing are the essential elements of any kind of service like that. What we have fundamentally and initially is the compute aspect, like devices with CPUs that can do a certain kind of computing or agent operations. However, in order to create a network of servers out of them, the persistent storage, we would have to add a new abstraction layer, basically, that would provide redundancy and resilience and persistence, so that if people unplug their phone, for example, or are disconnected, that there would be redundant storage, kind of like BitTorrent or some of the other distributed storage, like Filecoin, for example, distributed storage that operates with redundancy across a number of different devices, which may come or go, right? So we see that storage capability and service as a roadmap item that we are coming towards. But that's one of the beauties of last mile load testing, is that it doesn't require persistent storage. You're using the devices to go collect data from the server under test by hitting it with a request and measuring the response time. So you're kind of creating data out of the response times and sending that back fairly quickly, but you're not storing it forever, right? You're sending it back.
Got it. Okay. So if when it comes to cell phone, right, people definitely care about their privacy, correct? So
yes, of course.
When it comes to Neocortex platform, so how the privacy of a cell phone user is being taken care?
Yes, that's a fundamental question. So we have spent an enormous amount of our effort in making our system secure in two directions. So when I say two directions, what I mean is there are in principle two parties that are accessing the phone when our device is in use in a commercial case. There's the person who owns the phone, and then there's the customer who is trying to do work on the phone. So perhaps using this device as a load generator in a load test, for example. So we have the owner of the phone, and we have the cloud services customer who is using the phone. And of course, we have to have complete isolation between the people that are involved in using the processor and the memory. So we've spent an enormous amount of time building a secure container that we install onto the phone, and that makes it so that the owner of the phone cannot see what's happening inside the container. That is, there's process and file system isolation. So they cannot see what processes are running inside the container, and they cannot see what data is being stored internally inside the container. So that protects the customer from being snooped on or having their data manipulated or processes manipulated by the owner of the phone. And then, of course, we have to protect in the other direction. I think this was the concern that you were implicitly raising, Naveen, was we also have to make sure that our customer doesn't do anything to harm the owner of the phone. So, for example, they should not be able to break out of that container and be able to snoop on the contents of the phone, to be able to look at the owner's videos or access their microphone or camera, anything like that. We have to isolate them entirely inside the container. So we have to have two-way isolation with both the owner of the phone and the customer unable to see what each other is doing. And we've achieved that. But that was one of the biggest investments we had to make as a company. It took us about 2 years, about $1 million, to build a full, secure Linux container that would be isolated in both directions.
So every cell phone is a Linux container in Neocortex platform.
That's right. That's right.
So what are the limits you set, Lloyd, when it comes to CPU or memory? For example, Pixel 5 has, say, octa-core and 8 GB of RAM. So what is the maximum CPU limit you will be utilizing from the end user?
I believe that we've set it at maximum of like 95% CPU. We don't allow the container to completely take over the phone, and like disable the UI, for example. That would be bad if it did that. However, one of the things that we haven't mentioned yet, which is pretty important here, is that we only use the phone when the device is plugged into the charger and when it's connected to Wi-Fi. Right. So the intention is that we're only using the phone when the phone owner is not using it. Now, there's two scenarios when we expect that the phone owner would be allowing access. The first one that comes to mind is the idea that, well, when you charge your phone at night, when you're sleeping, you're not using your phone. And that's when you're connected to your own internal Wi-Fi network and you are plugged into the charger. So those two signals, plugged into charger and connected to Wi-Fi, are an indicator that the phone would be available and could be used by a customer's process. And so we structured it from the beginning that that's when people would be paid, the phone owners would be paid when it would be available, when the phone would be available to be used for a compute instance in a service similar to Amazon EC2. Now, that's not the only time, though, that the phone might be available. Or not the only scenario. The other scenario is we recognize that people have more than one phone. Often people will have their previous cell phone and maybe 2 or 3 generations of cell phones in the past sitting in a closet or sitting in a bedside table drawer, underutilized or not used at all. So we allowed our providers to have not only their main phone, which would be available typically 8 hours a day at night when they're sleeping, but we also allow them to have their spare phones, and up to 5 phones total available to us. And now those spare phones are particularly valuable to us, and they're particularly valuable to the phone owners. Here's why. We pay proportional to the amount of time that they're available to us, connected to Wi-Fi and connected to the charger. Well, the main phones for those users are available 1/3 of the time, whereas the spare phones are plugged in all the time. So that means that the people make 3 times as much money because they're being paid 24 hours a day for their phones at the same hourly rate. So they love those spare phones because they get paid so much more for having them. And we love those spare phones. We really love those spare phones because those are the ones that have high reliability. They're unlikely to be unplugged after being available to us for 8 hours. They're available 24 hours a day, 7 days a week. So they become our most reliable service. And we actually measure the device availability rating, which is essentially 100% if the device has been available for the last 48 hours consistently, never unplugged, no breakages in the service, just always available without ever disconnecting. And so that's how we can offer data center-like reliability on devices which may come or go, is we keep track of the ones which are coming and going, and we give them a low score, and the ones that get the high score, those are the ones that we prioritize when we're giving devices to customers.
Got it. So if a customer comes to you and they want to test with multiple regions, last mile, right? So they can easily upload their test plan and then they can easily test, correct? That's the whole idea. And suppose if a customer wants, I want to test with 4G or 5G LTE. So whether the Neocortex has support for that?
So no, we don't. Because of the characteristics that I described earlier, we want to make sure that we're not using up people's data plans. And so that's one of the things we had to give up, was that we do provide measurements of response time to last mile, but through residential networks and through Wi-Fi. At least we don't currently allow people to use their cell phone data connections, so their 4G, 5G, 3G connections. So you could see that as potentially one limitation. However, we still think that is adequately described as a last mile response time, because it truly is measuring. I mean, that's the if I was shopping now in the scenario that I'm in right now, I'm at my home connected to Wi-Fi. This is in fact where I do most of my shopping, is at home connected to Wi-Fi in these scenarios. So, but anyway, to answer your question, no, we don't currently offer that. We offer only Wi-Fi connections and through the residential data
Got
network.
it. Okay.
We have had people ask for that, though. I think it would be fair to say that it's a potential roadmap item. If we had customers asking us specifically for that, we would be willing to enable that additional service. Phone owners have occasionally asked us, they've said basically, I've got a all-you-can-eat data plan. It wouldn't cost me any more. Don't worry, you wouldn't be running me out of data for my data plan because it's all you can eat. So I wouldn't mind offering my service that way. So for those people, we would be willing to enable them to make money all the time, and therefore enable measurement of real cell phone networks.
Got it.
But we didn't do that initially.
Got it. Okay. Yeah, we have Arjun, Pavan, Sainath. Hi guys. If you have any questions, please you can interact with Lloyd.
Okay, you can go ahead. Sorry. Hi, Naveen and Lloyd. This is Pawan here.
Hello,
Hope
Arjun.
I'm audible.
Hello. Yes, I can hear you.
Yes, Pavan, please go ahead.
Sorry. Okay. Yeah. So thanks, Naveen, again for bringing me into this room and introducing me to this wonderful set of people. And hi, Lloyd. I've been. I think we are communicating on the LinkedIn, and congratulations for probably bringing in this technology and this performance testing platform solution provider, which could be a game changer down the line. But interestingly, for the first 5 minutes, even though I was a part of this room, but I could not hear the conversation properly. I thought the conversation did not begin, but I had to quit and rejoin the room back again. So whatever the understanding I have currently, based on the description that you just provided, I just had maybe 2 or 3 questions. Currently talking about the typical classic cloud ops load testing solution provider, which are in the market currently. Today, either it could be BlazeMeter or Flood.io or any other provider. So, what could be the cost of ownership and the return of the investment? Let's say about 500 users. Let's take a base example of 500 concurrent users, and you gave us a clear description of what are the unique features, the comparison between the distributed last mile load testing services that basically these the cloud ops load injector providers who are there in this industry for the past maybe a decade, compared to the Neocortex service provider.
Yes.
So that's one thing that I wanted to check, because since we are working in a service company, what boils down to us is how the return of investment and how cheap would be for us, when we compare it with owning any other service provider, right? So that's the key thing that I want to check. And the second thing is, you explained us about mobile load testing with distributed, load injector hops, located across different demographic locations, right? So I just wanted to check, because as you clearly pointed out, the realistic production mobile testing, it's all about testing on the mobile data, but not exactly on the Wi-Fi, with the factors that you are aware of. And then you clearly said that could be the feature that is added. But however, you know the challenges of the latency and the ISP providers and various challenges across different geographical locations. So what I was probably under the impression that if we are using maybe mobile phones, probably there could be a satellite-driven, load generators or something like that, which is obviously not Wi-Fi related. So that was my impression. That's the impression that I had. So, so that's one clarification that I wanted from you. And
of course.
The third question I had is, I will definitely visit the website after this and probably reach you out if in case anything, for any requirements down the line. But what are the key, what are the key differentiators of cloud native and cloud enabled performance testing services and integration areas, with respect to observability or with respect to deep diagnostics of APM or site reliability or chaos engineering that Neocortex can offer. Where are we talking about any interesting plug and play takeoff kind of solutioning here? So these are the three questions that I wanted to ask you. Back to you.
Very good. Very good. Okay. Thank you very much, Arjun. So yes, I'd be happy to address those three questions. So the first one is about cost. You phrased it as a total cost of ownership. The way that I normally think about it is just a direct comparison in between the costs for a given test for comparing between using the Neocortex network of devices versus using the more common scenario of a single large server or a small number of large servers in a data center like AWS, Azure, or Google Cloud Platform. So we're comparing the cost of using many small devices on the Neocortex network versus the cost of using a small number of large, powerful devices in data centers. So there it comes down essentially to the cost of instance time on Neocortex devices versus the cost of corresponding compute capacity instance time on data center devices. And for that, we devised our pricing strategy originally in a way that was intended to be that we would price our devices at approximately half the cost of Amazon or of AWS for a given level of compute capacity. And the way that we set that pricing and benchmarked it was by doing a computing task. It was originally, we did this in 2016. We benchmarked the best devices that we had at the time. Galaxy S6 was available at that time, which was one of the first octa-core processors with a very high performance A57 ARM processor. So it was a leap forward in processing power. So it made it a good candidate to be a good server. And so we benchmarked that on a rendering task against a PC and against AWS servers and set our price. Basically, there were some fairly complicated benchmarking processes. We found that this ARM device could do rendering at approximately a third the speed of a full PC using a quad-core i7 PC. So we took all that into account, and we essentially set the price of our best gold ranked devices at 5.5 cents per hour, and with the expectation and the belief that the performance of those devices was comparable to an Amazon, I believe it was a C4 large, which was priced at 10 cents per hour. So approximately we set the compute capacity for a at 1/2 the price, at least at that time, of an AWS device priced at 10 cents per hour. So that was our original intention, was to set ourselves at a price discount relative to the comparable amount of computing that you could get at AWS. And the reason, of course, there is that we wanted to be less expensive than the leading provider, AWS, so that anyone who was considering trying us would experience a discount, approximately 50% discount, to switch to us or to evaluate with us. And then the other aspect of the economics then is that then we would have to pay a fair price to the owner of the phone. And so our intention there was we gave ourselves 50% margins. So essentially we would take whatever we were paid, our 5.5 cents per hour, split that evenly with the owner of the phone. They would get 2.75 cents per hour, and then we would get the other 2.5 cents. So essentially, phone owner gets paid, we get paid equally for the time on the phone, and the customer gets a discount, and everyone wins. The only party that doesn't win in this scenario is the large data center provider who may lose a small amount of business. But as far as we can see, that's a drop in the bucket for the huge data center providers. So it looked to us like a win-win situation, and the pricing strategy was one that could appeal to all the parties. So it was enough to pay the phone owners to make them interested to do it, enough to give us a chance to stay in business with reasonable margins, and enough to attract customers with a reasonable discount. So that was the general idea on pricing. Since then, the devices have continued to evolve. So AWS offers over time better and better capabilities for the same price. So they aren't a stationary target. They get better and better over time, but so do we. Now a Galaxy S6 is no longer the best device around. In fact, it's a pretty much obsolete device. It's 5 years old. It is now a bronze category device, and a Galaxy S21 is the new current gold standard from Samsung, and the device performance of that is over double what the performance of an old Galaxy S6 was. So basically, Amazon and Neocortex have both benefited from Moore's Law, or the new incarnation of Moore's Law, where price performance is still improving every year with better cores, better frequencies, better processors. So that's our first answer to the pricing. It's the price question of the cost question. But it's not quite what you asked. You asked about total cost of ownership, and what I'm talking about is a incremental price, or a price for a given job to be done. So 200 devices. Let me just be specific. 200 devices at 5.5 cents an hour is $11, and with 200 devices, with 40 virtual users per device, that would be a load of 8,000 virtual users. So that's a reasonably large test. It's not huge. It's not the biggest that we can do, but 8,000 virtual users is one size, and the cost of running that is $11 on our devices. So if you would be able to compare that to AWS, whatever number of instances you need with whatever capacity you would need, you would have to price that out and find out what that would cost you to achieve that load effect from AWS. But then also you would have to compare the value of having it done with the last mile capability versus with the estimate of performance that you get from measuring directly from a nearby high-performance data center, which is going to be underestimating the response times relative to real-world response times. Finally, to the question of sort of total cost of ownership, that's generally something I think of when people are buying devices. Like, for example, if you were provisioning your own on-prem devices and actually buying them and paying up front for the cost of the servers, incremental cost of the air conditioners in your data center, the maintenance people to run them, and so on. That's generally how you calculate the total cost of ownership of these devices, which may be used for many jobs and over a long period and amortized and depreciated over a period of time. You get your total cost of ownership of those devices. Whereas Neocortex is not doing that. We're renting devices over time and only paying when we're using them. We're only being paid when we're being used. So it's kind of like saying, what's the total cost of ownership for you in taking a ride on Uber? It's not exactly I don't think the way that we think about that. The driver of the car in the Uber scenario certainly would think about his total cost of ownership, his or her total cost of ownership, right? But the customer is just renting time and having the experience of riding in the car just for that one ride. So if you want to discuss further about and elaborate a little more about how you'd like to think about the total cost of ownership, I'm definitely open to doing that. But I think of it more as a price per hour, 5.5 cents per hour, comparable to 10 cents per hour for AWS. Okay, so I'm going to pause there just to see if I've reasonably addressed your first question.
So basically, Neocortex is more affordable than any other players in the cloud computing, correct, Lloyd?
That's how we've intentionally priced it. Now, but I will give you this full disclosure, honest caveat that we set that pricing essentially in 2017 based on a rendering task. We didn't do it based on a load testing task, right? So it's possible that for load testing, that the economics might be different than for rendering. For a compute bound task, it could be that an additional recalibration would be needed. So at the moment, the only real way to do that, and I guess this is something that we need to do now pretty soon because it's becoming this is our bread and butter. So we really need to do the comparison, spin up whatever device would be possible to use for an 8,000 unit virtual user test on AWS and actually price that out. What would it cost to rent that for an hour versus our 200 devices at 40 virtual units per device? Now, there's a reason that we put a limit of sort of a rule of thumb, 40 virtual users per device, because we found in really analyzing the scatter plots of the data that if we overload any of our phones with too much processing, running JMeter, for example, that we find then that the response times become artificially large, not because of the actual transit times, but because the phone would be overloaded, right? So it's too busy handling the requests to be able to accurately measure the response time if it's in the overload condition. And of course, we don't want that. So we found that it's safe if you've got 40 virtual users per device and there's a reasonable pacing, as we've seen with our customers, that there's a certain amount of think time. You're not just blasting them at full speed for each user. So if you have reasonable scenarios, we find 40 to be a reasonable way of doing it, reasonable limit. And in that case, then we're safe and we're not overloaded. But in order to do a fair comparison with AWS, if you're going to have a single server simulating 8,000, well, that's actually probably a pretty high performance device then. I would expect that, that's not a 10 cent per hour device that would be able to simulate 8,000 virtual users. So that's where the pricing comparison would come in. If it would be, I think it still remains to be seen if it's, if that high-powered device is still twice as expensive as the larger number, the 200 smaller devices, all carefully not being put in the overload state.
Got it. Pawan, what was your second question? Sorry, I lost track of it.
Well, the second question I had was, how different was it compared to the cloud ops load testing service providers like BlazeMeter or FloodIO? But if this, the first answer seems to kind of answer that. But however, when we talk about the one key interesting aspect that I had to add into the question was, the purpose of this cloud distributed load testing was to, if I'm not wrong, is to reduce the carbon emissions and have a positive impact on the climate change, right? So that is the one important aspect of cloud testing and kind of cloud ops and all this stuff, right? So if we are using more of mobile phones to test, wouldn't that be a kind of have a bad impact on climate changes or carbon emissions? So that is the other thing that I wanted to bring in. And I believe Neocortex architecture is more about data and event driven or EA kind of an architecture, probably for resilience is what Lloyd talked about, right? So more of reliability and elasticity putting together. So, and then what I was under the impression that if it's not a mobile data driven load testing but a Wi-Fi, so I was under the impression that maybe phones are available through a satellite mode or something. So that is the other question that I had. And final question I had is, sorry, I kind of lost on the final question that I had to throw.
No, final question was about observability and APM.
Yeah. So the final question I had was,
sorry, I muted. Yeah.
Yeah. So the final question I had to Lloyd was, when we talk about observability, APMs, and this performance engineering aspects. How good is Neocortex with respect to integrations to all the other hybrid tools and all the other performance engineering tools. So I think those are the three takeaways.
Okay. If I may then, so shall I focus on the second question, which in the rephrasing of it has sort of brought in these bigger issues, which I didn't catch on the first one about sort of climate change and sort of global impact. I'm not 100% sure that I've really got the gist of your question. So I'm going to say what I think I'm going to try to answer. And if I've got the question wrong, then I'm going to give you a chance to correct me. So it sounded like you're asking me to comment on the global impact of this distributed network of mobile devices, how it would compare strategically to the conventional data center approach. So is it better for the world that we are using people's phones, or as compared to using large servers in data centers? So is that the Is that the nature of the question? Sort of global impact on climate and environment?
Yeah, that's correct, Lloyd. I resonate with you on that. So that's precisely my question was, because if we are using, mobile phones and we are more exposed to, all the, this waves and all the stuff. But so
Okay.
that's the question that I had. But anyway, I mean, if that's
shall I answer that then?
Yeah, sure, Lloyd.
Okay, so so that's the question that I will try to answer. So we generally look at this as a kind of a green solution that is very much advantageous and preferential to the climate and to the environment. The reason being, so now this actually is a case where it does make sense to think in terms of total cost of ownership, not just dollars, but in terms of environmental impact. So here, if you compare the cost of what a company like AWS has to do, which is when they want to increase their capacity, they buy new servers and they put them into their data centers, concentrate them into a single location, their high performance devices. They pay twice for the power that they consume. It's a large amount of power for these devices that has to be brought into these data centers. And then because they're concentrated in one place, they generate a lot of localized heat, which has to be dissipated using air conditioning. So they pay twice to heat up their facility with the computing, and then they pay once to do that, and then they pay a second time to air condition it and cool it down. So that's the way that they are doing it involves buying new devices and powering them in an inefficient way, in a heat inefficient way, and having to air condition it to keep it cool. Whereas what we're doing is using devices that people already own. There's no purchase of a new device. There's devices that have already been bought and served a useful life in a consumer sense. So we're reutilizing something that has already been used for its original intended purpose. So in that sense, we see that as kind of like recycling or reusing a product. So we think of that as the ultimate in a green solution, reusing devices that have already been purchased. And then from a heating point of view, because the devices are not concentrated in one localized place, yes, you pay for the power that they consume to do the job, but they don't heat up your place so much that you have to change the air conditioning in your home. Now, it's partly because the device is so inherently efficient. These are ARM devices, which have been made to be battery powered. So the industry has put an enormous premium on making these devices power efficient so that they don't run down the batteries when they're used as normal phones. So they're efficient to begin with, so they consume less power per compute than the Intel servers that are commonly found in data centers. And because they're not concentrated in one place and therefore have to be cooled, they're sitting out on a table and have normal airflow around them. There's no need for specific air conditioning to cool them specifically. They fit into people's lives where they're already being, the environment is already being air conditioned. And this adds virtually nothing incrementally to the air conditioning needs of a given home. So we think for two reasons, for those many reasons, that our solution is more environmentally friendly, lower carbon footprint, and better for the environment than the highly concentrated data centers. That's my answer on that. Does that address your question, or is there something else that I should also address that I missed?
No, Lloyd. I mean, I resonate with you on that, and thanks for putting it in an elegant way. So yeah, I'm okay with that.
Okay, good. Now I think there was another another part of your question that you mentioned about DevOps and integration with other tools, and how does Neocortex compare in those ways? So shall I address that question next?
Yes, please, Lloyd. Thank you.
Okay, very good. So the first distinction that I would like to make, or this sort of a clarification about what is it exactly that we offer. For example, we don't think of ourselves as a tool competitor. For example, we don't compete with Microfocus LoadRunner or Tricentis NeoLoad, for example, or K6 or Gatling. We are not producing a load testing tool that competes with those other load testing tools. We're not making the software. We're providing the instances they run on. So if to the extent that we're competing with anybody, we're competing with AWS, Google, and Microsoft Azure for providing instances to you for running your software. But we are as agnostic as we can be about what software you choose to run. So we make it possible so that you can run load tests on our devices using JMeter or NeoLoad or K6, Locust, Gatling, and those are the ones that we currently offer. And in fact, we've got other capabilities that go more into the observability part, which you have mentioned. For example, an integration with Dynatrace, an integration with the JMeter Perfmon plugin. So those are for correlating the performance that you may measure in a load test with the CPU, memory, and network metrics that you can measure. So you can find out, the load test is telling us that the performance of the device is slow of the server is slow under load, and we can see that the CPU is becoming limited when it's getting loaded. So, it's a CPU problem. Or we can see, no, it's a network problem internally, or it's running out of RAM. The garbage collection is the problem, right? So those observability concerns we address as, not as a device provider, but by allowing integration between your load testing tools and integrating with Dynatrace, Perfmon, and other observability tools. In addition, we also there's a different kind of observability. This is more like synthetic user monitoring, where you can also use our devices not just to do load testing, but to do front-end testing. So things like Puppeteer and Lighthouse, we've had requests for those additional capabilities so that you could do a load test that measures the response times to the real-world user and end user locations, and then you could have also devices in those locations that are not so much delivering load, but they're measuring the render time and the actual response time perceived by the user. So you could, in principle and in practice, have the most thorough measurement of end user experience possible. More thorough than could be done any other way, because you'd be measuring the real render time on real devices under load that was created by last mile response time load generators. So you could have literally the best of everything, the most thorough end user response time measurement possible using our devices. Now, I don't know how many performance engineers are that ambitious. They really want to measure all of those things. When I speak to most of them, I find that that's like, getting your PhD in high performance end user experience. And what I find is most engineers in practice are using a single data center, a single device in a single data center that is very close to the website server under test. It might even be inside the same data center. So there's a wide continuum of ambitions in how much of the end user experience to measure. And the most common scenario is to measure the least accurate estimate of end user experience by just using a single data center. I find that there's a sort of a long tail of distribution with a much smaller number of engineers that are willing to consider measuring end user response times, and then an even smaller number that are also wanting to measure render times and combine all of these into a full measurement of the total distribution of end user experiences. Now, if I may, I'd like to just kind of make that, there's a key point there. It's about the fundamental purpose of performance testing. It's to measure the collective distribution of end user experiences to make sure that the end customers of your website services are getting the expected performance, and that should be in unloaded conditions and in loaded conditions. So we want to make sure not only that devices don't crash, or the servers don't crash on Black Friday, we want to make sure that they don't slow down excessively also on Black Friday. So I've heard the phrase that slow is the new down, right? That if the device becomes so slow that it's unacceptable performance while shopping, people will abandon the shopping cart just as badly as if the website crashed. So it's important that we measure the response times fully under load, including the render time and including the response times all the way out to where people actually live and shop. And so if performance engineers are doing either A, what they're used to, or A, what is convenient, that actually is creating a problem in the industry, because the performance engineers are the people who are tasked with determining whether the performance is acceptable to the end user. The CEO of United Airlines is not independently measuring that. Right? He's going to trust that the company that he hires, Cognizant or Infosys or Capgemini or Moritech, any of the companies that are doing the performance testing, that they will make an honest, good faith measurement of the end user experience. And if those companies take the easy way out and just use a data center nearby, or even in this, a server inside the same data center as the device under test, then they will be dramatically underestimating the response time that an end user will receive. And so now we can set up this horrendous disconnect, something that is harmful to the industry, not just to the customer, but to the industry as a whole. It has a big consequence. If we have performance engineers underestimating the response times and signing off and saying, we've done our test, looks like we'll handle it on Black Friday, everything's fine, response times will be good, because we measured it in this false way with an underestimate of response times. And then Black Friday really hits, and now you have people sitting on the couch saying, why is this website so slow? Because they're measuring the real response times with the real rendering times and the real path out to where they live, the living room in Oklahoma, and their Wi-Fi connection. All of that adds up to response delays that are longer than what the performance engineer measured. So now we have a disconnect. We have a conscientious performance engineer who doesn't realize that he's underestimating the response time. So he confidently says performance will be good. And because the measurement has been flawed in this optimistic way, it's confident but incorrect. That is the worst possible scenario for a performance engineer. It's sort of a doomsday scenario. Performance engineer says performance is good when it's not in practice. And it's because, in my opinion, it's because the industry has gotten used to measuring it in the convenient way. It was the only way that was possible to do it in the past. That's a problem. And that's the problem that Neocortex fixes. It allows you to measure it accurately, and it gives the performance engineer the bad news that the performance measured by perceived by the end user is worse than what you get if you measure in the data center, it's important that not that the performance engineer gets bad news. It's important that they get the truth. They should get the truth of what the real end user performance is so that they can optimize the performance correctly. And now, this is a key point, that the performance engineer is creating an optimization loop. That is, the performance engineer doesn't just do a load test. That's sort of the performance tester does the load test. And they get a measurement of the response time or the distribution of response times. But then the performance engineer has to optimize based on that. So if the performance is perceived to be too slow, like it doesn't meet the service level objective, then they must improve the performance of the server software and perhaps the hardware. Maybe they have to install more servers or allocate more devices or fix that bottleneck in the database or do whatever they have to do. But they have to go to work and optimize the performance. And then once they've done it, and they think, okay, we've just shaved 400 milliseconds off that server response time. Now let's do another load test and see if the performance is now acceptable. And so they do a second load test. And hopefully what they find is that, okay, now it's acceptable. If it is, then they stop optimizing because they now meet their service objective. So this question of when do they stop optimizing, when do they terminate their optimization loop is the key thing. If they have an underestimate of response times, they will stop too early. They will think that, it's Miller time. It's time to go for lunch. We've optimized it and everything looks good measured here in our data center. So they stop optimizing. Whereas if they had truly measured what was being perceived in the living room in Oklahoma, they would say, we've got to optimize, we've got to improve it by another 1.2 seconds to account for the actual end user last mile response time. This is why last mile load testing is so important. You have to take that extra 1.2 seconds, sort of worst case, into account, and it puts a really high burden on how much more optimization you have to do at the server level to actually get great performance perceived by the customer. So not terminating your optimization loop is the key. And it's not that we're giving you bad news. We're giving you the truth so that you can truly optimize to get the end result for the consumer that you're actually the performance engineer is being tasked to do. Okay, I'm going to pause there. That was a long answer.
Yes,
very important.
I agree with you, Lloyd, because as a performance engineer, right, we tend to focus on one thing. Whether back-end performance means people focus only on the back-end performance. And
yes.
there could be numerous reasons, right? I mean, management or time constraints, and then it will not be in scope for them. So there could be a number of reasons where we cannot spend in all the aspects. But yeah, as you mentioned, we need to expand our visibility into all the aspects of the application. Yes, I agree with you.
Agreed. That phrase that you used about focusing on the back end, that's one that I've heard other very well-respected performance engineers have used that. Very senior people in the field said, well, when I debate with them about the importance of doing this, and that's an answer that I often get, I prefer to focus on the back end. Okay, well, you focus on the back end, that means you are not focusing on the end user experience. You're not measuring it, and that is the job that is to be done. It's the end purpose of the job to be done.
That's correct.
So
yes.
in this sense, I consider that this is addressing not just a concern for a given customer, the job that's being done for that customer. This is a problem that affects the entire industry. If the entire industry abdicates the responsibility of measuring the real user response time, the industry as a whole suffers. And I actually, personally, I believe that we are seeing effects of that. That the performance engineering and performance testing industry experiencing a kind of decline because it is losing its relevance to its true purpose of making the performance good, optimizing the performance for the end user. It's become a specialized niche industry of improving database performance times and improving performance as measured locally at the server. And that disconnect between the end user is making it something that it's losing its relevance in the business sense to the funding sources. The CEOs are wondering, well, is this relevant? But I'm paying all this money for performance engineering, and people are still complaining that the website's too slow. Right? That disconnect is being perceived, I think, implicitly by the people who do the funding. And the way out of this industry-wide problem is to raise our standards. Basically, don't do the thing that is convenient, the thing that is easy. Don't look for the keys under the lamp. Look for them where you dropped them, right? That old joke about where dropping your car in the parking lot, but I'm looking over here where the light is better, to try to find them. You have to do the hard work of really measuring the end user response time. Yes, it's more work. Yes, it takes more time to do it right, but it's the job that must be done. And if one engineer doesn't do it on that job is weakened. But if all performance engineers don't do it on all jobs, the industry as a whole is weakened. And that is a big problem. I personally see the effects, the corrosive effects of this collective behavior, or not a behavior, but of a belief system that is affecting everyone in a subtle way. And the only way around it is for each individual performance engineer to commit to raise their standards and really measure end user experience. Their performance will become better. Their company will be raised by it. The performance engineering industry will increase in its value. People's jobs will sort of come back or have greater longevity. The pay for being a performance engineer will go up as people raise their standards. That's the kind of initiative that I perceive is needed in the industry. Okay, anyway, that's my soapbox on that. I think it's important.
Yes. We have a couple of folks, Sid, Shravanti, Venkat. Hi, Sid. Thanks for joining.
Thanks, Naveen and
Yeah,
Lloyd.
please go ahead with your question. I think you're waiting for a long time. Yeah, please go ahead.
Yeah. So thanks, Lloyd, for a brief explanation and everything.
Thank you.
Yeah. Let me put my words, what I understand. So these automation tools, like any load testing, like JMeter or Neoload or Load Runner, any tools came into picture when it was not possible to do the real load testing, the term you called at the end load testing.
Yes.
It was not possible. Now you're making that as a possible, right?
Right. We enable it really for the first time. So it's an enabling technology. Yes.
It's going. The tools came into picture when it was not possible. You're making it possible to bypass the tools. So that's fine. That's good. And one more thing, I want to comment.
Not to bypass the tools, to actually allow them to serve their true purpose by being run on the right machines in the right places.
True,
but yeah,
true.
we're not bypassing. We're enabling them to do the job right now.
True. Yeah, I put some pessimistic way, so sorry about that.
Yeah, there you go. Okay.
Yeah. So, and one more thing, I have a question. Like, I thought of asking more in terms of monitoring perspective. So when it's so how you're help me understand here. You're scaling your device, then you're allowing them to test on your device, right?
So you're scaling your devices.
Like you're allocating that, you're saying that my device is 5 octa-core and this much RAM, so 40 virtual users you can test on that, right?
Yeah, that's right.
True. So that means no need to have any monitoring like CPU memory. You already setting a max CPU of 95%. That's initially you said, right?
Yes, that's right.
So are you saying directly no need to monitor my end real user? in terms of resources, at least, not in terms of response time or rendering anything.
So I think I see what you mean. So you're saying, are you saying monitoring the whether the load generator is in a unloaded condition or a satisfactory handling condition? Is that what you're saying?
No, I'm talking about in terms of end user device. So now it's a real user, right? So
yeah.
So are you saying no need to monitor this one in terms of apart from the response and rendering times?
Lloyd, I think Sid was mentioning about the devices, CPU and memory when the test is running.
Yeah, but the load generator device.
Yes, correct.
So our phone. Okay, right. So that is what I was trying to say. So my understanding is that most load generation tools, most load testing tools, have the ability to monitor the health of the load generator itself to see if the load generator is in an overload condition. Right? Is that? I think that's what you're asking about.
Correct.
Monitoring
yes,
that. Correct. Okay. So for that, we haven't yet had a customer ask us to do that, and so there's every reason that we should be able to do that. But so far, no customer has said, "I actually want to verify that you can do that." So I can't point to direct experience with having done that for a customer. What I have done is I've run many load tests in enough different conditions. Sort of, I and my team have run it, and we've pushed the limits of having more than 40 virtual users per phone. We've had, for example, weaker phones where we've put hundreds of virtual users onto a given weaker phone. And what we've seen there is that the response times become unexpectedly large. And so that's an indirect indicator that the device is in an overload condition. And so we're not really, in that case, we're not measuring end user experience. We're getting a false pessimistic reading it's worse than what a real user would experience, because a real user is not pretending to be hundreds of users on one device. So we should not overload it. So that's how we came to a kind of empirical rule of thumb that about 40 is safe, and 40 on a good phone, a gold phone, and 200 on an old bronze phone from 2017 is unacceptable. So we've kind of measured that anecdotally and empirically, but actually measuring it directly by reading the CPU characteristics and performance it's not something that we have yet done. And I'll give the sort of the additional caveat. It's something that we can do in principle. However, our lead engineer has told me that in order to do that, we have to get access to some /proc files deep inside the Linux subsystem, and it will be some engineering work to be able to do it. So it's not something that I can just sort of enable in a second. I would guess that would be potentially a week or maybe even a little bit more time to enable that capability and be able to get that diagnostic. So I think the best I can say is really doing that measurement would be a roadmap item that we could do in a reasonably short time if it was requested by a customer. But we haven't yet had that request by anyone for implementing the function yet.
Yeah, thanks, Lloyd. That makes very sense. And I think if you name it as real load testing, real performance testing, that would be more suitable than what you named. And one last question. So if I have a powerful device which could be used for you, how do you approach me? I mean, as a company.
powerful device. I mean, like if you have a big gaming machine or something like that.
No, yeah.
So at the moment, so that's a good question. That's another roadmap item for us. Currently we support only Android devices. And I'll make the initial or this small detour. People often ask us, "Can I run Phone Paycheck?" It's our app that pays people for renting time. Can I run that on iOS? Could I run it on my iPhone? And the answer is no. We don't support iPhones or iPads, iOS devices. Because we don't believe that we would be permitted to run the necessary background processes, persistent background processes on iOS devices. So generally, that's not allowed except for audio players and map applications. But otherwise, applications are blocked from using persistent background devices, and of course, we need that to provide reliable service. So maybe.
My question was like, even if it's Android device, so how do you approach end users? So we will run our tests. So how do you approach the customers?
Sorry, how do we? I don't quite understand the question. How do I persuade the customers?
No, you are using the real mobile device when they connect to the Wi-Fi. It's somebody else's phone, right? Not your company's phone number.
Any phone.
Yeah, any phone. So if you want to use my phone as part of your company, so how do you?
Okay. I think maybe it's just you mean how do you sign up to provide your phone to our service? Is that what you're saying?
Exactly. Yeah.
Oh, okay. Sorry. Yes, I guess I've had all that implicitly assumed that people knew about that. So the way that people sign up their devices is they install an app that we have created onto their phone. So they're volunteering to do it and in exchange to get paid for doing so. So they install Phone Paycheck. So if you go to the Android, the Google Play Store, and you search for Phone Paycheck, you'll find this lovely little app. It's a rather plain user interface. It just looks like, it shows you kind of a bank balance, shows you how much money you've made. From the point of view of the owner of the phone, it's an app that pays you for doing nothing. It pays you in US dollars through PayPal for literally doing nothing. You're just renting out your processor with no effort from you. So it looks a little bit like Airbnb. You're renting out your home, you're renting out your processor, but it's not like Uber where you actually have to drive your car. You've got a job that pays you dollars per hour for being a driver. There's nothing like that. You're just renting out this asset that you own. So that's how you access it, is by installing the app on your phone. And then there's another key step, though, which is that we then have to activate your device. At first, we activated all devices as we were virally growing. But then we hit a limit of how many devices we could afford to pay for before we had paying customers ourselves. Remember, this is a shared economy business. So the providers of the compute capacity are the Phone Paycheck users who are getting paid. And in our initial development phase, we have to pay them even though we don't have customers. So it's kind of like what Uber would have to do at the beginning of a launch in a new city. They would have to pay drivers to be driving around on the roads even before there was any riders, right? And so there's a little bootstrap process that a company like Uber would have to do. Pay a bunch of drivers, get them out there and promote to the riders and get the riders out. And eventually you get a balance between the number of riders and drivers. And then you can kind of grow it organically then, and you can stop subsidizing the drivers, right? Well, we're just on the cusp of that right now. We've been subsidizing our providers, that is our Phone Paycheck users, and we've been paying them even though we didn't have a substantial number of paying customers to us. So that's cost us. It's cost us dearly, actually. We've been doing that for 4 years now, since we launched in 2017. I can tell you that we've paid over $1 million to pay people to make their phone processors available to us, even though we didn't have anyone paying us. And that's personally come directly out of my pocket. Right? I put $2.5 million into the company, and over 1 million of that has gone to paying people to bootstrap this process of having an available resource that we could then develop on and use to demonstrate to our potential customers. So if you evaluate Neocortex load test now as a load testing service, you'll be running on devices that we've been paying for 4 years. But your cost of ownership. Your cost of ownership is extremely low, right? Because my cost of ownership is very high. I've been paying all these people even though I didn't have a customer coming in. It's an investment that I've been making in creating a two-sided shared economy business. But that upfront investment is substantial. To have a viral growth on the supply side, now we need the viral growth on the demand side, the customers. And the good news is we're just about to get that now. I'm seeing good uptake in the industry. But yeah, we have to balance out our supply side and our demand side. And what we need now is Neocortex load test customers to come and try it and start actually using this amazing resource, increasing the demand for devices, and then we can grow from the 3,000 devices we've got activated to the 90,000 that are on the waiting list. Phone Paycheck is an extremely popular service. People all over the world love to get paid for doing nothing, and paid US dollars. By the way, we're not doing some crazy coin thing. This isn't, Neocortex coin. There's no cryptocurrency aspect of this. We're paying US dollars through PayPal all over the world.
So suppose I'm running a Raspberry Pi cluster at home where I use for Kubernetes, Pi-hole and all. So can I enroll into the program, Lloyd?
No, you couldn't. Unless this Raspberry Pi was running Android. Right now, we're supporting only Android.
Okay.
In principle, it could be done, but it would just be an additional interface that we need to support. So on our roadmap of additional devices, the roadmap that we have is continue to support all flavors of Android and new security enhancements. Google makes it harder and harder for us every year. With every new version of Android, we have to do something to make sure that we can still run properly and don't have our processes killed and stuff like that. But then we go from there. Extending to PCs would be next, not because we need more devices. We're not running out of devices. We're never going to run out of devices. There's 2.5 billion Android phones. We're never going to run out of phones. We're limited on the demand side, getting people to use our service much more than we are limited by running out of devices. But the reason that we would have a roadmap item to go get some PCs, it's not because we need more computing, but it would be good to have even more powerful devices. A PC is 3 or 4 times the performance of the best phones that we've got. And then if we could augment that with not just PC CPUs, but with NVIDIA GPUs, then we could have a credible entry into the deep learning market, for example. Right? So our general purpose compute capacity we would look more like a real competitor to Amazon EC2 because we would have devices that could reach up into the high end. Right now, we're limited to competing only against the low end. So we have a roadmap to address that, but it's not our biggest concern at the moment. Getting customers for our load testing service is our primary objective right now.
Sure, got it.
Yeah.
Okay, we have Shravanti. Hi, Shravanti.
Hey, Naveen. Hi, Lloyd.
Hello, Shravanti. Nice to have you on the call.
Yeah, Lloyd. Same, likewise here. So, yeah, it's not a question, but I would just like to provide my review to other performance engineers here. So, yeah, I have thoroughly evaluated their product and we have partnered with them as well, Neocortex. So, yeah, I have at least the complete information of end to end. What are the questions which most of them have been covered here. So just few review points which I would like to give. So it's as Lloyd had already stated, it supports most of the available load testing tools in the market, be it JMeter, Neoload, or Gatling, or K6, whatever you name it. They are supporting it, and the best thing which I have observed is like, how you have your Blaze meter and other portals wherein you could do your JMeter testing. Neocortex is equivalent to that, actually, with an additional benefit of doing this last mile load testing. So definitely it's a win-win when you have to compare with any other cloud portal load testing tools which are available. So yeah, and I've seen the tool. I think one of the best thing which I have observed is like the support. If you need certain feature, I think Lloyd and his team are very quick enough to incorporate, which I haven't seen that kind of support even in commercial tools, wherein we pay huge amount for their support and maintenance. But if you have to get any feature added, it really takes a number of months or even years. So that's one of the great thing about their tool. And yeah, it's finally it's like you get best sophisticated reports like your any other tool, and they have few additional benefits of the reporting feature as well. So yeah, other thing I think one of the which Lloyd was highlighting, other aspect where apart from load testing, we could also do certain website monitoring. Probably you're using a Lighthouse. So if you have to run your Lighthouse across different locations in US, it's very easy to do on this compared to your EC2 or any other VMs. So yeah, those are the vital points which I thought of specifying here.
Oh, very nice. So great to have you on the call, Sravanti, to mention those things. I think most people know that Sravanti and Moritech have been incredibly wonderful early adopter partners with us. We've announced the Moritech Neocortex partnership about a week and a half ago. Having Sravanti really not just evaluate, but really exercise, really push our capabilities over the last several months. It's been so valuable to have such a highly qualified early adopter to, it's pushed our service beyond what I could have imagined that we would have been able to do a few months ago. And having such a experienced and knowledgeable early adopter, has allowed us, well, what Sravanti said about providing support for new features. Yeah, we went through half a dozen cycles there with a turnaround time of generally about 2 days to when Sravanti would request some new feature that she felt that we needed to have. And, we would work on it like our lives depended on it. Basically, okay, we got to do it. And Dimitri and Michael would drop whatever they were doing to make it happen and turn that feature request around. So yeah, I can confirm we are indeed responsive to customer requests. Sravanti is the proof of that. And our newly launched product, Neocortex Load Test with the convenient browser interface, the origins of that were in feedback from Sravanti and from other members of her team who were essentially saying it's pretty inconvenient to ask the performance engineers to have a Linux machine lying around to be able to use. And we need to be able to provide a convenient access and a reliable access. Basically, Neocortex should take care of that. We should have a controller that runs on a high-performance data center. That part does run in a high-performance data center, the controller to our last-mile devices. And so we responded to Sravanti's request for that. That one took a few weeks for us to fully build because it was a whole new type of service. But yeah, it's been great to be able to respond quickly to a customer's requests. We're honored to be able to do that. And Sravanti's pushed us. It's like a drill sergeant. Give me 50 push-ups. All right. Yes, sir. Let's do it. Let's make this happen.
Yeah, that's nice.
Yeah. Thank you so much.
Yeah, as a CEO, you have to listen to everybody's. Right?
Yeah. Sorry, recent deliveries, is that what you said?
No, everybody, you have to listen to everyone's voice, right? Otherwise, we cannot improve the product.
Oh, of
Correct.
course. Yeah, no, so we're very happy to have early adopters. Cervanti has really been our first very strong one. However, there have been others as well, too. So going back even earlier, Naveen Kumar himself and Harinder Sira and Paul McLean were the first people over a year ago who tried the new service out when we were just offering the batch runner capabilities, and all of them provided additional feedback and input to us on how to improve it. So we've been improving steadily with input from all of these experts in the field who have been helping us with their feedback. And the latest incarnation of that, the most recent one, was a really strong engagement with Moritech and with Cervanti in the lead on that. So appreciate that from all the people who have tried it, and others as well too. There were other people who took our certification program maybe 6 months or 8 months ago. Everyone has contributed in some way to us improving the service. We're keen for the feedback, and we'd welcome anybody else who wants to give us a try now. Anyone who tries it now gets a very thoroughly baked and convenient interface. Now, with 2 clicks, you can launch your first JMeter test. No need for a Linux machine. No need to know Linux at all. Just a convenient browser interface. Select a preset, hit launch. You're running your first, sophisticated the JPET store demo, full reporting, and then you can get the files and modify them. We've made it really easy to use, and again, that was thanks to the really expert feedback and guidance from Cervanti on how it should work in these advanced scenarios.
Yeah, thanks, Lloyd.
Thank you.
Sid, do you have any question, Sid?
Yes, one last question, Lloyd.
Sure.
Yeah. So it's not a question, like it's a doubt. Like, how do you decide the geo user loads? Like, it should be running from the South America, North America, or in the world UK. Is it a requirement should come from the end customers, or you decide?
Well, no, you can request that. So if you look at our demo, you go to sign up for your free account, go to the load test button and go to launch a test, and you'll see that there's a field there. You can request how many devices you want, and you can request what regions you want them to run in. So you get to decide that. If you leave it by default, then you leave it up to us, and we choose at random devices all over the world, and wherever we have them available to us. But if you wish, you can specify sub-regions. So, for example, USA only, or India only, or Asia Pacific, or Russia, South America. You can ask for whatever devices. And then what we show you is, as you make your selections in real time, then we show you how many devices we have available for your test. So if you say USA, we have most of our devices, our single greatest country is US. So if you ask for US, you'll see, 90 devices currently available with unique locations, and 374 devices available where they may be co-located, right? So there's a distinction there. We assume that you want devices in really unique locations, but remember, people are allowed to have up to 5 devices. So if we're not careful, we might give you 2 devices from the same little farm in somebody's house. Right? And that's not.
So that being said, all the 5 devices should be active, always need to be connected. How you notify them? Like, there is a requirement of your location load test. You connect your device and make it sure it's connected to Wi-Fi. Is that way, or it should be all the 5 devices should be active every time?
No, any device can be brought down or disconnected. So if all 5 devices are available when the time comes to launch a test, then they become eligible. And if we're asking for non-co-located devices, then we may choose one of those 5. But if we're asking for non-co-located, then we won't choose all 5 of them or even 2 of them, right? Because we want the devices to be in unique locations with different IP addresses and different actual neighborhoods that they come from. Right? So, but we treat them as available devices, but with a grouping based on their location. And if we can, if you ask for a reasonable number of them, then we can provide you with devices that are guaranteed to not be in shared locations with each other, non-co-located.
Yeah, thanks a lot, Lloyd.
Yeah, and by the way, that was also a request that effectively came in from one of Sravanti's colleagues, because he noticed that when we would draw the map of devices, we were getting co-located devices, and so he would ask for 6 devices, but it would look like 5 points on the map. And that's because sometimes 2 of the points were in the same house, right? So it only looked like 5 points, but it was actually 6 with 2 co-located. And so we had to spend several days modifying our device selection algorithm to select only unique locations. Turns out that's hard to do using programming in PostgreSQL, right? See, I mean, easy in Python, but try to do that with PostgreSQL requests. Turns out it's kind of tricky.
Hopefully you are not ended with each coordinate is a unique location. Each coordinate, like okay.
Each location. No, we are treating that as a unique location.
Oh, got it.
Yeah. So, for example, we do have scenarios where there are several people in the same city, but we don't treat them as co-located, right? It's only if they're in the same household that we treat them as co-located.
Yeah, thanks, Lloyd.
Thanks, Sid. We have Sudhagar. Hi, Sudhagar. Thanks for joining us. Yeah, if you have any questions, you can ask. I think he left. That's fine. Okay, thank you everyone for joining this. I think he is back. Sudhagar, are you there?
Yes. Hi, Naveen.
Hi. Yeah, if you have any questions, you can ask Lloyd.
Actually, in this session, I don't have any questions.
Okay.
What and all information provided by Lloyd, I am fine with that.
Okay, cool. Thank you, Sudhagar. Thanks everyone for joining this Clubhouse meet. So, quick update on October 6th. Please check it out. Loadtestworld.com, conference by Redline 13, which is free and 100% virtual. I'll be speaking there, and also there are a couple of folks like Leandro, Dave, Eldad, so they'll be there. They will talk about various topics about performance. So please check it out. Loadtestworld.com. And yeah, with that said, we can wind up today's session. Session is being recorded. Once it is available, I will publish it in my YouTube channel.
Naveen, sorry.
Yes, Pawan.
Sorry, before signing off, I just had one question to Lloyd.
Sure.
This will be very quick and will not take too much of time. And also maybe to Shravanti as well, because she has used this product for quite a while now. So first of all, I just wanted to give my appreciation to Lloyd, for the insights, and he has hit the nail on its head when it comes to why the performance testing and engineering field has declined, with respect to the scope and various business objectives and all the other factors. So he's absolutely right. Second thing is, regarding this business model of, using platformation and more consumer centric of, offering the solution, seems to be a very good, aspect for us also maybe. The question that I had is, is there a technical capability deck or, tool-wise comparison deck or any, I would say, white paper or anything which can I basically use to, to probably, once I go through the create an account and do some proof of concept and then probably showcase to the, to the management or to whoever it is.
Yes.
So, yeah.
Certainly.
Yeah.
So Sravanti asked me for that about 2 months ago. So I created a slide deck that was intended for a performance test lead or a performance engineer to use to persuade, or, to discuss with their management about the virtues of this tool and perhaps recommending it. We need to arm you with some collateral so that you can convey the advantages. So I can share with you the deck that I gave to Sravanti for that purpose. In fact, I guess we should just put that on our website. That this is something that an early adopter performance engineer will need. You have to then get budget approval to start using the tool, right? So you have to persuade people that what the virtues of the tool are. So would that address your question? If we shared that deck with you?
Yes, Lloyd, absolutely. Because I am kind of now working on probable prospect. I mean, we haven't, as a company, we haven't gone to any vendors for an out and out licensing, but it's all customer based licensing on demand. But if in case, if something goes well, we do have our own, sales department for, tooling. Probably if a technical deck goes well and if a proof of concept goes well, someone might reach out down the line as well. The other final question I had, it's not again, it will be very brief. I mean, we have our end-to-end stack, hosted on AWS EC2 cloud, which is hybrid. And then with whatever I understand with the testing tool infrastructure on the Neocortex front, right? I mean, as I understand, it's all mobile handset based with whatever the app that is installed and the agent that runs to spin up the, the browser interfaces or whatever to connect to the EC2 instances. So how complex is that to run a test behind the firewall or behind the NAT, on AWS EC2 instances? Should all the thing be, should that be a DMZ zone, or should there be a security group, interference? So how firewall or NAT driven testing, could be done? That's what I want. I mean, should there be a IT ops interference at both the on the test infrastructure side and the test tool infrastructure side as well?
I don't think so. So first of all, there was something you said in your question that I'm not sure if I understood right. It sounded like you're thinking that we might be running Neocortex software on EC2 devices, like inside a data center. That's not something that we're doing. We're running whatever your testing software is. If you're running JMeter or NeoLoad or Catling or K6, we're simply allowing you to put your load generators on these mobile devices that we provide for you. So you get to run your testing software, load generators, on our mobile devices that are at people's real world last mile locations. So where the real load would come from on a real Black Friday with real users, we're letting you get your load to happen from there. But there's no Neocortex software that we are trying to run on an EC2 instance or inside some other data center. We're simply acting as an orchestrator. We orchestrate all of these devices to make them available to run your load generator software, whatever tool you want. You can run it on us. Does that answer your question, or does it clear up a misconception?
Yeah, fine, Lloyd. I mean, I think I will get in touch with you offline. We can keep it very short. But I got your point. I mean, that's what I was trying to ask. I mean, it's not that we'll be running the Neocortex apps on the instances of EC2. I got it. So that's the reason I put it into two different things. One is all our test environments or the servers are in the AWS EC2 within a particular region. And the other thing what we differentiate is what we call it as normally is a test tool infrastructure. So the test tool infrastructure will be the load generators or load injectors along with the testing tool, whatever the testing tool that we use. But I will certainly connect with you offline.
Okay,
Back
that
to you,
sounds
Navi.
good. Yes, I'd be very happy to discuss it with you offline, for sure.
Yeah. Thank you, Lloyd. Thank you, everyone. With that said, we can wind up the session. Please check it out, YouTube channel for the recorded audio. Thank you. Have a good weekend.
Fantastic. Thank you, Naveen Kumar. That's really enjoyed being on your panel. Thanks.
Thanks, Lloyd. Thanks, everyone. See you. Bye.
Bye.
Thanks, Naveen. Thanks, Lloyd. Thanks, everyone.
Thanks.
Thank you.